Grades for you guys are up to date. I made sure of it over the break. So if you go check JMC, you'll see that everything's in there. So if you're missing something, like you forgot to turn something in Google Classroom, like where you just didn't submit it to me, make sure that you're going and taking care of that before, winter break and stuff. Try to get that all wrapped up and taken care of. So everything's in. I made sure of it last night and everything. I went through the grade book, and the hard part is going through email, because some people like email me stuff. Oh my God, that's a nightmare trying to figure that out. So, I received like 1,000 emails over the last couple days, so it's just going through it. I can't find them all. So, if you submitted like some work to me via email, just remind me that you did that, and I'll go back. I got some emails about like retake tests. They're in. So, if you did better, they're in. If you didn't, it's not showing up. Sorry. So, but yeah, we'll hand back some papers. We're going to start reviewing the semester tests tomorrow. So. So we're going to start the practice guide for the semester test. You'll get a physical copy in your hand. We're going to do that the next 5 days in here, like Thursday, Friday, Monday, Tuesday, Wednesday. Then we're out for winter break. We come back. Monday we're back from winter break. It's like second or third of January. We'll do that as a review day, because I'm sure you'll forget some stuff from then. We'll kind of refresh your memory on what to do. And then Tuesday is our semester test. So, questions? Perfect. Okay, let's take a few notes here today. I just basically want to do just a problem, one single problem, and then I'll give you some time to kind of work, because I only have you for the next 20 minutes or so. I just want to do a problem on hyperbolas. So it's been a while. I haven't been here to talk about it, and you've been trying to learn via Zoom. Hopefully that kept it as normal as possible. It's not going to be perfect, but I tried to do the best I could to try to get you just to a normal class. It's probably really weird just seeing me do notes like right here, but let's kind of go over the basics here. So the hyperbola, the formula, the generic formula for it is, it's something like x squared minus y squared equals 1, and then we have some numbers down here, a squared and b squared, right? And so this is the generic formula, right? Now this type of hyperbola, by just looking at this formula, this is a horizontal parabola, or hyperbola. How do I know it's horizontal? So in fact, I'm going to put that up here. It's horizontal. I'm going to grab some new markers. These are terrible. Okay, so why I know this is horizontal, when I look at this problem, we notice that it has the minus sign. So that tells me it's a hyperbola right away, right? It's got that little, it's got the two parabolas kind of going outwards. They're called hyperbolas. But the idea is that this item's in the front. That's how I know which direction it's going. The fraction, because there's two fractions here, whatever fraction is positive, this one's the positive one, or it has a positive sign out front, that's the direction we're going. So we're going along the x-axis, so it's going horizontal. So if these two were switched around, then it would be vertical. So we'll kind of look at that, and I'll show you kind of the example of that, so as we get going. What we've been doing is taking like an equation and like rearranging it to get it to look like this, correct? That's what we've been doing. So we've been doing completing the square and getting down to the point where you get to some numbers. So I'll let you guys just make up some numbers. I need two numbers. Just give me any two.
8 and 5.
7 and 5. All right, I heard those. So 7 and 5. So positive 7, 5, and what was the other numbers I heard?
8
8?
and 2.
2. Okay. So 7 and 5 and 8 and 2. All right, 8 and 2. Okay. So let's talk about how we can go figure out the parts, right? Because that's what your homework's based on, right? You completed the square, got it to here. Oh, this is supposed to be a minus sign. All right, so we get to this part, and now what we have to do is read off the center, go after the asymptotes, figure out where the branches go, that's called the transverse axis, and then figure out, where the foci are located inside this. So, how we do this? Number one, the center. It's really straightforward. Whoa, this marker is terrible. The brand marker, come on. Work in progress always. I've used an old one. All right, so the center. What are the opposite numbers with x and y? Negative 7 then? Negative 5. All right, there's my center. So that's number one. You can read off the opposites. It's pretty easy. You guys are pretty familiar with doing that. Now, the figure out where the branches go, like the hyperbolic branches, where the transverse axis is, because I know it's going outwards, right? I know like the generic look of this thing, you know, it's over -7, so it's over -7, down -5, and that's where the center is. The branches are doing this type of thing. Now, again, how I know that is because it's horizontal. This fraction in the front tells me that. The x was positive, this fraction was positive, so it's going right and left. So now, how do I figure out where the branches start? You have to take the square root of this bottom number. So, the square root of 8, now, which is not a clean number, it's almost the number 3, right? It's like 2.8 or something like that, right? So the square root of 8. Somebody have a calculator on here?
It's 2.8.
2.8? Oh, I just guessed. There, 2.8. All right, so 2.8. That's how far right and left I'm going, right? So square root of 8 going to the right, 2.8 this way. So 2.8 this way, and 2.8 this way. And that will get me to where the branches need to start. Now, how I write those as coordinates, you add this number or subtract this number from whatever direction I need to go. Well, I need to go right and left. So what I'm going to do is I'm going to add this number to the x, because it was below the x's. So, -7 plus 2.8, comma -5, and -7 minus 2.8, comma -5. Does that make sense how I added it to the x's? If the y was out front, then you'd add it to the y number instead. So you add it to whatever the major axis is, or transverse axis. And that's where you'll actually hit the branches. So it'll hit what? About -5.2-ish, and or 4.2-ish, and then -9.8 that way. So those will be the numbers I'll hit. All right, questions with how to find where the branches start. Now, technically I'm not supposed to be drawing the branches because I would need to find the asymptotes first, but obviously you're not having to draw anything yet. So I don't really care that I haven't drawn this really accurate yet. But is there any questions with the first two pieces? Okay. And now for the next part, the asymptotes. This is the undefined boundary. How this works, it's always y equals, and it's some fraction x. That's how it works. It's y equals mx plus b form, right? It's that slope-intercept form. How this works, look at the number that's below y. So in this case, the number below y is 2. I have to take the square root of it. So you're always going to take the square root of that. Whatever number is below y. I don't know where y is. Go find it, take the square root of that number. That's my rise number. So the square root of 2 is about 1.4. So that number goes here, right? Whatever that square root of 2 number is. It's 1.4. If you want to put 1.4, put 1.4, right? And then for my other number, the square root of 8, that's the number below x, right? That number is going to go on the bottom, whatever that number is. And we said that was 2.8. And that's the fraction for my asymptote. So again, if you want to put it as decimals, I'm totally fine with you doing that. 1.41 and 2.8. Right, if you want to write it like that. Now, what that means is from the center, I'm going up 1.4 and over 2.8. Right? And so this is what my asymptote is going to look like. And then down 1.4 and over 2.8. And there's my other asymptote, because you can go positive or negative. And that's why I want the asymptotes, is because that tells me how far I can draw the branches. Maybe they need to be really tiny, maybe it needs to be really wide, who knows. Okay, questions with how I set those asymptotes up. Rise over run, y number over the x number, whatever's on the bottoms. You have to take the square roots of those. I think I did a really goofy one yesterday where I did like fractions in there, where I put, instead of decimals, I did fractions. So you can figure out how to do the reciprocal and stuff. So look back at that example. Okay, and then the last thing we have to do is the foci, and this is the absolute last thing I want to cover today. The foci, what color am I on? Am I in green now? All right, so foci. Okay, so to do the foci, this is that formula you have to know. For a hyperbola, it's basically the Pythagorean theorem. So that one's pretty easy to memorize. On an ellipse, I think it's a squared minus b squared. So, so the only difference is a plus or minus sign. So on a hyperbola, it's a squared plus b squared. Now the good thing is it doesn't actually matter which one's a and b. The book always refers to as the one out front, the transverse axis, as being a squared. Doesn't matter because you're adding them anyway. So this is just 8 plus 2, right? That's my a and b number. A squared here and b squared here. Doesn't actually matter which one's which. And so this turns out to be a 10. And what do I have to do to solve for c? Square root. The square root of 10 is just above the number 3. 3.16. Okay. That's an approximation. So that means from the center, I'm going 3.6 and 3.6. And again, you always add that to what your transverse axis was. So my center was -7, -5, and I'm going to add that 3.16 and subtract the 3.16 from that x number. Now again, why I'm subtracting it from the x number, from the center, is because that's the major axis, that's the path I'm traveling on. I'm traveling on the x-axis. So 3.6 this way, 3.6 this way. And there's where the foci are located. Again, the foci are always inside the hyperbolic branches. It's like the eye of the satellite dish. It has to be inside where the dish is pointing towards. Questions? Okay, your question of the day today is I'm going to give you these numbers. These numbers. And what I want you to do is go backwards and tell me what the formula was. Go backwards and tell me what the formula was. So I'm telling you what the center is. Go up and plug it in. I'm telling you what your asymptote was. So I'm telling you your rise and run number. So you can square these numbers, put them to the power 2, and then you can put them back to the bottom. And that's what I want to see. I want to see what your original formula was. It was really simple. You don't need to have, I don't need to give you the transverse axis. I don't need to give you the foci, because all you need is the asymptote, and you just need the center. And you can take those two and go right back to here. The only thing you need to know is which direction are you going? Is it going up and down, or is it going right and left? So they'll tell you in the hints. Okay, now we have homework due tomorrow, correct? I'm going to give you some time in class tomorrow to work on that. Remember, the goal tomorrow is to really review this semester test, so the practice guide. So we're going to do that in the first half of class. Maybe we'll do like 3 or 4 questions. And then the rest of the time I'll give you time to work on your homework. So this is the question of the day. Can you take some basic information and go back to what the formula should have been? So pay attention to that. Let's see if you guys can do it. And we're going to use that question as our guide tomorrow. Again, it's just a trial and error. Don't feel like it's a huge assignment. It's just a question. I want to see if you guys can do it.
Can you come with us? Okay.
Sound good? Yeah. They knew both to read them almost out.
So this is one of the questions from homework tomorrow, and I got like a -4. So like, how do I take the square root of that?
Okay, so that one's negative. Did this one turn out to be positive then? It must have been. This one turned out to be a positive. So this one will go up front, and this one will stay second. So it's actually a vertical one.
Can I go to our
Yes. Because you divided everything by -4, right? So this one turned out to be negative, and this one was already negative. So when you divide it by -4, negative turns positive. So this item, this thing right here, should go to the front.
So it should be a positive 4.
Yeah.
So you take 1 divided by 3, 1 divided by
No, you'll just leave a 4 down here, because this 4 will go to the bottom, so let's stay at 4. This one will be a 1/4, because you're taking both divided by 16. So that'll be a 1/4 on that side. Just type in your correction, so type in the square root key, and then type in your fraction. 5 divided by 16. Like that. Should I type that in? Square root 5 divided by 16. Oh, I'm typing parentheses in it. Square root 16.
And then, you just leave it like that and add a negative to it?
And you can even do it as a decimal. There you go. Yeah, are you sure that was a 5? I thought there was a 4 over here. I thought this was a 4. I'm gonna double check that. I think this is a 4. I think it worked out to be prettier numbers than what you have.
Is that,
Yeah, yeah. And then you divide this by -4, so that turned out to be positive. And divide this by -4, and this will turn out to be a negative, and this will be a fraction down here, it'll be a decimal.
and then right here, if it's vertical, you put 1.
Yeah. Yep.
So what do I do later? So I have -1/4. So what do I do later when I'm trying to?
That'll turn positive, and that'll be.
So you'll have to take a square root of that, so 1/4 is like 0.25, so you have to
It's
take
a
a square root.
negative, you can't.
The negative just goes up front, you just put the negative up front.
You don't worry about it.
Oh.
We'll figure out
Yeah,
that
because
out.
negative sign can go out front, it's still the same fraction.